Hey students, in this video I'm going to summarize what the notes of 7.1 were about, which was introducing you to rational parent functions. The rational function looks like this when you first graph it, 1 over x. And initially what you want to see is that you have two asymptotes. You have a vertical asymptote at the y-axis, and then you have a horizontal asymptote at the x-axis. And then if you recall from Algebra 1, asymptotes are pretty much the graph is approaching these lines, but they never touch. So there's no value that can make this graph true wherever these asymptotes are at. So for example, if you look at the vertical asymptote, that's saying that the vertical asymptote is existing when x equals 0. That means that if I was to look at this graph and put a 0 here for the x, my answer is something that I cannot have. It will be undefined. So just a review on that. Whenever you divide 1 by 0, the answer is undefined. So whenever we have asymptotes, it means that we have found a location where values cannot give you, I guess, an output. The inputs won't give you an output. Like, it just pretty much makes no sense to have a value whenever you have that x or y value. So the vertical asymptote here is x equals 0, which is when it's touching at x at 0, and then the horizontal asymptote is y equals 0, because it's when y is touching the y at 0. One way to remember how to start writing it as x or y is remembering the shortcut of Hoy-Bucks. Hoy stands for horizontal, so any horizontal line will have y equals as an equation. And then Bucks will be the vertical lines, and then the equations will be x equals for vertical lines. So vertical asymptote is x equals, and then a horizontal asymptote is y equals. Whenever you find the asymptotes, you're also finding a restriction on the domain and range, because whenever you are asked to identify the domain or range, you're being asked to identify the values that the graph has or is using. So you're pretty much not going to say the values that it is using. Instead, you're going to say the values that it cannot use, because it's easier in this type of graph. So you're just going to say, based on the asymptote, the domain is all the x values except for 0, or except whatever number the asymptote is. Same thing for the range, since the range is y equals 0. I'm sorry, the horizontal asymptote is y equals 0. The range is affected by this. So the range is whatever the y cannot equal based on the asymptote. Y cannot equal 0. It'll make more sense when we do examples. So before we do examples, just a review on the transformations. We need to remember the a value. Transformation can tell you if it can reflect over the x-axis or across the x-axis whenever your a value is negative. So for example, the original graph looks like this, and if I was to reflect it over the x-axis, this curve will now be over here, and then this curve will now be over here. So it will look something like this. And then besides reflecting, the a value also tells you if it stretches or compresses. It can either stretch or compress. And then one way you can see that is whenever you graph it in your calculator and you graph the original equation, the parent function technically, 1 over x, and then you graph another example where the a value is not 1, it's any other number than 1. So let's say I type 3 over x. So as you can see, 3 made it go more this direction, which made it be a stretch. If I had a rubber band, you can visualize me stretching this rubber band this way vertically, and it creates that image that we see. So that's a vertical stretch, and then this will be a vertical compression. One shortcut to know which one is which: stretch is whenever the A value is greater than 1, and compress is when A is less than 1. All right, the next part is what H and K does in transformations. So similar to previous functions, H and K are the ones that change the direction. So H shifts the graph left or right, and K shifts the graph up or down. The trick part here is about H. H has to look like X minus H. So when it's X minus a negative number, it's going to end up looking as X plus H. But that negative number, or that negative H, is the amount that it moves to the left. And then for the right, it will look X minus whatever H value is there. And the H is positive, so it moves to the right, whatever number that amount is. Up or down, it's just what you see. So it's plus K, whatever you see here, or minus K, whatever you see there. And these are important to recall whenever you're using the asymptotes, because the vertical asymptote, which is again like this, will be on shifting whenever it shifts to the left or right. The vertical asymptote will move as well. So the one that moves left or right is the H value. So we're going to say that the vertical asymptote, it's going to be also whatever the H value is. So if it shifts 3 units, then the asymptote is now X equals 3. The domain is again just writing the restriction of X, set of all X values such that X cannot equal whatever the asymptote is. So we're just going to say H value in this case. Horizontal asymptote is like this. So the only way this can shift is up or down. So the one that shifts up or down is K. So for this one, we're going to have Y equals K. And then the range will be the restriction of Y such that Y cannot equal K, whatever your asymptote for the horizontal is. Let's do a couple practice problems so you can understand it a little better. So right here, example number 1, we have a function that has an A value of a 1, an H value of a 2, and a K value of a 3. So because the A value is 1, that means that there's going to be no change as far as the A description. So the descriptions for the A, it's reflection, stretch, or compression, but the parent function is a 1. So if your graph right now has a 1, that means there was no change in that. There is a change on H and K though, so we gotta describe here in transformations what H and K does. A lot of students graphed it first just to kind of see what it looks like. So I'm gonna graph it for you. And the blue is the parent function and the red is the new one. So you can guide yourself based on the curve. This curve is now over here. So it definitely went up and to the right in order to end up over here. As far as how much of each, then that's where you gotta look at specifically at these numbers. So we know that K is the up or down and H is the left or right. And based on this sketch, it went up and then to the right. So we're gonna say that it went up 3. So it shifts up 3 units and right 2 units. And to make this visually, we're going to sketch the asymptote. So the vertical asymptote originally is here at 0 when x equals 0. And if it shifted up, shifting it up doesn't really make a difference. Shifting it right 2 units does. So we're going to move it to the right 2 units. And this is where the vertical asymptote is at now, which means that you are going to specify that change. So vertical asymptote, it's going to be whenever x equals 2, because it shifted 2 units to the right, which means that your domain now has a restriction at x, all x values, such that x cannot equal 2. So all x values except for when x equals 2. And then the horizontal asymptote, we're going to say that it shifted up 3 units because that was our description. So if this shifts up 3 units, it's going to be touching at y equals 3 now. And that's where the horizontal asymptote will be. So we're going to write it as y equals 3, y, such that y cannot equal 3. All right, so then as far as how to sketch the curves, just go to control table and find some exact whole numbers that are following the new one. So the new one is the red one. So I'm looking at the top that's following the correct graph. So it looks like 1, 2, and 3 and 4. 1, 2, and 3 and 4 are order pairs that are the corners right here, the turning points. And then from there you can just sketch the curve of the graph. So the important part here is the asymptotes, not so much about the graph at this point. Just where are the asymptotes? Where do they move? So this is the example completed. You described it. You identify the vertical and horizontal asymptote, and you identified the domain and range for the graph. Try the next example, pause the video, and then press play whenever you're ready to check it. All right, so on this one, we have an A value of -2, H value of 4, and then there's no K value. When there is no K value, that means there's not going to be a change of up or down. The A value is telling us that we are going to have a negative A value, which again, if we look at our notes, when A is negative, we're going to have a reflection across the x-axis. So if we were to graph this, we would have noticed that it reflected. So let me graph that real quick. Okay, so the parent function is the blue one. And now notice how the curves flipped. So definitely a reflection. And then it also looked like it shifted this way. So let's talk about the reflection first. So we're going to say that it reflected over x-axis. And then that's only talking about what the negative does. So now let's talk about what that 2 is doing. So if I specifically look at that 2, once again, if you remove the negative and the 4, you can see what that 2 is doing to the parent function. So back to the rubber band problem, in order for you to describe this correctly, the blue is there and then the red one is on the inside. So we kind of had to stretch that. We have to stretch it vertically in order for it to go inside. Compressing it will push it down. So we are going to say we vertically stretched by 2. All right, so that takes care of that A value. And then the h value, x minus h has to be the template. If it doesn't look like x minus h, that means our h value is not 4, it's -4, x minus -4. So if your h value is -4, that means that it shifted to the left, because now we are moving to the left 4 spaces. And then as you recall from when we graphed it, it had the red lines over here now on the left. So it confirms that the vertical asymptote, instead of being at 0, it's now going to shift 4 spaces to the left. So this is where we draw it. 4 units left. Which means that our vertical asymptote is going to be x equals -4, and that means our new domain is going to be with the restriction of x such that x cannot equal -4. And then our horizontal asymptote, as we mentioned earlier, there's no change up and down. So we are going to have one. Don't forget to sketch it. We are always going to have asymptotes. This is how the rational functions look. They have a vertical asymptote and a horizontal asymptote. But because it didn't move, we're just going to say 0, because that's where it is originally. Y cannot equal 0. All right, now to sketch the curve inside, we want to just, once again, find a table and points that can be plotted. So -2, -1, -3, -2. These are these 2 points right here. And then if I keep going up, there's the undefined for the asymptote, and then the -5, 2, and -6, 1. -5, 2, -6, 1. And that's how it sketches the curve. So again, the important part is identifying where the asymptotes shifted and what the new domain and range restrictions are for these type of functions. Okay, I hope this video helped you.